Hi, everybody. This is Mrs. Harding. I want you to flip in your packet to the page for section 3.6b notes. You can see it on the screen there. These questions today are a little bit tough, so just take your time, give it your best shot. We'll go over these again tomorrow, but we're going to jump around in the notes a little bit. We're going to actually start with number 2. So take a look at number 2 there. For each of these problems at the top, it says what we're going to do. You're going to graph the function, making note of its domain, graph the inverse, determine the equation of the inverse, and then determine the domain and range of the inverse. So let's take a look here at number 2 to start with. To graph this is a parabola, but I want you to think back to your transformations. There's 2 horizontal transformations here. The first one would be going left 2. And then there would be a reflection over the y-axis. The vertex of this parabola is actually here at 2, 0. That's also the restriction on this graph, that x is greater than or equal to 2. So from here, we're going to plot points just with x values larger than 2. So when x is 3, we are at 1. When x is 4, 2, 3, we're at 4. Over 1 up 5, 1, 2, 3, 4, 5. There we go. So this is the graph of g of x. The domain for g of x, as given there, is from 2 to infinity. The range for g of x is from 0 to infinity. All right, remember what we said yesterday about the graph of an inverse is a reflection over the y equals x line. So you can estimate what it's going to look like, but you can also take the points and just reverse x and y. So 2, 0 goes to 0, 2. 3, 1 goes to 1, 3. 4, 4 is right on the line, so it's inverses itself. And then here we have 5, 9, so 9, 5. And this green graph is g inverse of x. All right, so we did part B, we graphed the inverse. The third part then is to find the equation of the inverse. So the equation of the original graph is this, y equals 2 minus x, all squared. Let's flip-flop x and y. So x is here, y is here, and then we're going to solve this for y. All right, well that involves taking a square root right off the bat, right? So this is plus and minus. Root x is equal to 2 minus y. If I want to solve this for y, I'm going to add y to the other side so that it's positive. I have to move this plus and minus root x here. If you do the opposite of plus and minus, it's then minus plus, or still kind of the same thing. So when you solve this, it's 2 plus or minus root x. Obviously, this is not a function. If I plugged in a number for x, I'd get 2 answers for y. So now this is when we need to come back to what the domain and the range are for the inverse before we decide, should we keep 2 plus root x or 2 minus root x? Well, the domain for this will be 0 to infinity, which should hopefully make sense to you because you're not going to put negative numbers underneath the square root. And the range is 2 to infinity. The range is all numbers bigger than 2 or larger. So what does that mean that you keep here to make the actual inverse function? You only keep the positive. So f inverse of x is equal to 2 plus the square root of x. And I want you to look at that green graph and think about your parent functions. The square root function shifted up too. That's exactly what we're looking at. All right, so like I said, we're going to jump around a little bit. So after number 2, I actually want you to go to the next page, and let's go give number 4 a try. All right, looking at number 4, this is a parabola that has been reflected over the x-axis, so it's opening down, and then it's been shifted up 4. So the vertex is 1, 2, 3, 4 right here. This time my domain is that x is less than or equal to 0, so it's from negative infinity to 0. That means I'm only doing the left side of this parabola. Oops, sorry about that. Hit the calendar. Over 1, down 1, over 1, down 1, 2, 3, over 1, down 1, 2, 3, 4, 5. So the function that we're working with is this function right there. This is g of x. Oh, I keep hitting that calendar. Okay, and the range for that, if you look at it, is from negative infinity to 4. All right, so we've got that graph. Let's do the graph of the inverse. We'll put that in red. Again, a reflection over the y equals x line. Or take all of these and reverse the x's and y's. So this is 0, 4. That becomes 4, 0 for the inverse. Negative 1, 3. Here. Here. And here. So if you're good with your transformations, you might even be able to write the equation of the inverse without doing the steps that we're going to do. But let's do this over here. We're going to reverse x and y. So this is going to say x equals 4 minus y squared. And I need to resolve this for y squared, or sorry, for y. I'm going to actually add y squared to this side, subtract x to that side. So it's going to look like this. Y squared equals 4 minus x. And then I need to take the square root. Y is equal to plus or minus 4 minus x. Obviously, again, not a function, so we have to decide, is it the positive or the negative that applies to this red graph that we're looking at? There's two things that you can check. First of all, you can check what the domain and the range are supposed to be for the inverse. The domain should be negative infinity to 4. And again, that should make sense because you can't put numbers bigger than 4 in for x and still get a real answer. And then the range is actually numbers 0 or smaller. So if I want 0 or smaller, that's negative numbers. So this is a case where you'd actually keep the negative. Or if you look at the red graph, this is a square root function that's been reflected over the x-axis, which means that there would be a negative in front. So the inverse function rule is the opposite of root 4 minus x. Okay, the next one that I want to do is number 3. Sorry, we're jumping around a whole bunch here. So number 3 has something special to it. For the last couple that we've done, we've started out with a parabola. This time we're not. We're starting out with a square root function. So the first step here to graph the original function, well, this is the square root function. It's reflected over the x-axis, and it's shifted up 3. So here's what we're looking at. Normally, you know, the square root function would look like a little arm above the x-axis. It's been reflected, so it'll curve down, and it's been shifted up 3. 1, 2, 3. So this is the beginning. 3, 1, 2, 3, 4, 5. And you can plug in numbers there if you're not sure where I got all those points from, just graphing that parent function. So this right here is the graph of f of x. What's the domain? Well, let's just look at the graph. The domain is 0 to infinity. The range is negative infinity to 3. All right, let's graph the inverse. Reflection over y equals x line. Reverse all your y's and x's. 1, 2, 3 is here. This is 1, 2, so we're going to go to 2, 1. This is the 0.4, 1, so we're going to go to 1, 1, 2, 3, 4. And then this is the 0.90, so we're going to go to 0, 9. So this is the graph of the inverse of x, and it should look like a reflection over that y equals x line. And we need to come up with the equation for this. So flip-flop x and y. This is x equals 3 minus root y. I'm going to add the square root of y to the left, subtract the x to the right. So we're looking at this. And now to get y by itself, you have to square both sides of the equation. So this is going to be y equals 3 minus x squared. And the domain and the range for this are just going to be the domain and range flip-flopped from the original. So the domain is going to be negative infinity to 3. The range is going to be 0 to infinity. Now this one has an extra little catch. Remember on these others, when you thought about the domain for the inverse, the domain, like if you look at number 4, the domain has to be numbers 4 or smaller. That's actually implied by what you're looking at, because you're looking at this right here, and to get a real answer, it's implied it can't be anything bigger than 4 or you won't get a real answer. However, when you look at this one, if all you saw was this equation, you would think that was a full parabola. It's not really implied in there that you can only have numbers 3 or smaller, because the inverse here is only half a parabola. So when you write this inverse equation, so f inverse of x is equal to 3 minus x squared, you must put the restrictions on x, that x has to be less than or equal to 3. That is the full answer for what the inverse equation is. Without that x is less than or equal to 3, you do not have the correct answer, because you'd be saying a full parabola is the inverse. Full parabola is not the inverse. So make sure on questions like this that you remember to put in the domain, because it's not already implied from the equation that you're looking at. All right, let's finally go back up to question number 1. The reason I saved number 1 for last is because this right here is not really in a form that's going to be great for us to graph. It's not in a form that's going to be great for us to find an inverse. So what I'm actually going to do with this equation is I'm going to put it in vertex form by completing the square. So this is x squared plus 4x. And to complete the square, that would be 4 divided by 2 squared is 4. Remember, I can't just add a 4, so I have to offset the change. But then that gives me this equation, x plus 2 squared minus 4. So now it's a little easier to graph. The vertex is at negative 2, negative 4. So negative 2, negative 4 is here. A is 1, so there's no stretch or shrink. X has to be greater than or equal to negative 2 where the vertex is. So I'm just going to do the right side of the graph. Over 1 up 1, over 1 up 3, over 1 up 5. So this right here is f of x. We've got a domain of negative 2 to infinity. We've got a range of negative 4 to infinity. All right, then in black, I'm going to graph the inverse by flipping all of those points around. Hope you don't mind if I speed up here a little bit. Negative 4, negative 2. This is going to be negative 3, negative 1. 0, 0 is on the line. There we go. So this right here is the inverse graph of x. Now, when I do the inverse equation, I'm not going to use that original one. I'm going to use the one that I put into vertex form. So I'm going to say x equals y plus 2 squared minus 4. Add 4 to both sides. Square root plus minus root x plus 4 equals y minus 2. I'm going to add that 2 to the other side. And now, based on what the domain and the range should be, the range for this should be from -2 to infinity. Oops. I messed up my sign. Here we go. That should be plus. That should be minus. So if it's got to be -2 or greater, then the inverse is keeping the positive. So the inverse function is -2 plus the square root of x plus 4. The domain is implied. It's -4 to infinity. You don't have to specifically write it on the end of the equation like we did the last one. And then the range is going to be -2 to infinity. Okay, so now what I want you to do is, let's go to question number 5. And I want you to just pause the video and I want you to give number 5 a try on your own, remembering what we did with that last question, how we completed the square first to get the quadratic into a better form. So go ahead and pause the video for a second, and then when you have your answer, unpause and you can check your work. Okay, you can check your answer there to number 5. F of x, the graph is in black, the inverse is in green. Complete the square to put f of x into vertex form. Then to get the equation, you flip-flop x and y. Recognize in the inverse that the range or the output should be -4 or greater, so that indicates to keep the positive out of the plus and minus. That's all I'm going to do in this video. Number 6 is a challenge. The video is already long, so I'm not going to go through that, and it's sort of just an extra extension anyway. If you want to give it a try, go ahead. I'll give you a hint. It is a circle. But that is it for today. So if you're good with all of those notes, go ahead and get started on homework 3.6a, and I will see you tomorrow to go over any questions from the video that you want to ask. Enjoy the rest of your day. Bye.